Hi, welcome to Lesson 5E, Financial Mathematics, where we're going to be using some technology to help us out. We're going to take a look at page 121 in the textbook first. So I'll kind of hop over there now and just kind of show you what the textbook says. So we're on page 121, and if we're using technology for financial models, what we're going to be using in the TI-84 is the Tvm Solver, and that TVM stands for time value of money. So a few short forms or initials, abbreviations we need to know. N is the number of compounding periods. If the investment is being compounded per year, then it would be the number of years, but generally it would be like if it's quarters, it would be the number of quarters over the entire life of the investment or loan or whatever it may be. I is the interest rate per year, not per compounding period. The calculator can do that for us. PV is the present value of the investment. And present value is generally the negative because a lot of times that's the value that we're going to be investing. We're going to be the money is going to be leaving our pocket and going into the bank. So that's why it's going to be negative, because it's moving away from us. PMT is the payment each time period. Well, we're going to get into that a little bit later when we talk about annuities. But for right now, we're just going to leave that one blank. FV is the future value. And that value would be positive because that's the value that we end up getting. It comes back to us. P-Y is the number of payments per year. And C-Y is the number of compounding periods per year. And usually those are going to be the same. That'll be the same value. If it's monthly, they'll both say 12. If it's quarterly, they'll both say 4, etc. A little note down at the bottom, N represents the number of compounding periods, not the number of years. And I is always a percentage interest rate per annum or per year. Okay, so let's hop back over to the smartboard for a second. And we'll take a look at our TVM solver. So I'm also going to look at this on our web at EMU. So here on the side of the smartboard, we see that we've got the display of this application. So Sally invests $15,000 in an account that pays 4.25% per annum. That's per annum, and it's compounded monthly. So the interest rate is 4.25%, and that's per annum. Now 60 is, well, it's going to be in for 5 years, but it's compounded monthly. So that is 5 times 12. So we have to put that value in, the number of compounding periods. The amount that she invests is $15,000, but that's leaving her and going into the investment or in the bank or whatnot. So that's why it's going to be negative 15,000. And then it's 12 and 12 for payments per year and compounding per year. And what we need to do is we need to figure out that future value. So we'll cursor down to FV, and then we'll do alpha enter. And like I said before, the alpha is green, and on the calculator, which I'll show you here, oops, can't draw on that. I'll have to show this to you now. Alpha is a green button, and written on the calculator in green by the enter button is, oh, don't see it here, is the word solve. Okay, so we would do alpha enter, and that solves the problem for us. So in N, I'm going to put 60, because that's the number of months. That's the number of compounding periods. It's 4.5. No, sorry, this one is 4.25% per annum. And so notice that once I changed the payments per year to 12, the compounding per year also changed to 12. And then all I have to do is arrow up to future value, and then I'm going to alpha enter, because alpha is green and the word solve by the enter button is green, so that means that the alpha will control the enter, and it'll solve for the future value, and we see that there's an A flashing there for the alpha, and I press enter, and we get $18,544.53 will be the final amount that Sally gets after 5 years of her initial investment of $15,000. Okay, so we're going to be using the TVM solver on the graphing calculator for the next couple examples. So we will just continue with that. So we're going to deposit $6,000 into the bank account that pays 5% per annum, compounded monthly. So it's already set up for compounded monthly because it's payments per year and compounding per year is both 12. It's going to be 2 years, so I'm going to go up to N, and it's going to be 2 times 12, which will be, of course, 24. The interest rate per year is 5%. The initial investment is $6,000. Of course, it's negative because it's money out of our pocket. We're not going to worry about the payment. We'll get to the future value, and we will enter, and that gives us, alpha, enter, is $6,629.65. See if I can write this here. So N, was 24. The I, the interest rate, was 5%. The present value is the amount that we invested, so that was 6,000. The payment we're leaving blank, but the future value is what we're interested in, and the payments per year were 12, and the compounding per year is 12. Now the payments per year, that doesn't really have a big effect on this one because we're not worrying about the payment. Okay, the payment is going to be like a consistent payment, but we're not going to worry about that in this case. So basically the payments per year is moot as well, and the future value ends up being what we are looking at. We're looking for $6,629 and 65 cents. And notice that that is positive because that is money in our pocket. Okay, so now I'll move on to the next example. A couple inherited $40,000. They deposited it into an account paying 4.5%. So I can put this in here. So they're depositing $40,000. So we'll put in 40,000. The interest rate is 4.5%, and that's per annum. And they want to leave, now it's quarterly, so it's being compounded quarterly, so it's going to be 4 times per year, and same with the compounding. And they want to leave it in there until there's 45,000 in the account. Okay, so we've got everything set up, and I forgot a 0 here. So I add one more 0. So it's 40,000 to turn into 45,000, and we want to know how long they want to keep the money in that account. So we go up. So the payments and the compounding per year is already in terms of quarters. So the value that we get here will be the number of quarters they have to leave it in, and then we can convert that into years. So we're going to alpha enter, and it's 10.5 quarters. Okay, so the interest rate again was 4.5%. The present value was what they invested. That's negative 40,000. The payment again we're not going to worry about. The future value we want to see when it hits 45,000. the payments per year and the compounding per year, because it's 4 times per year, it's quarterly. So we're just going to put 4s in there. And I should probably write that C a little bit neater. And then, like I said, the payments we're not going to worry about. And the N is what we're trying to find. And as it turns out, it gives us, it's about 10.52, but it's 10.5 quarters. And so after 10 quarters, so 10 quarters is 2.5 years. And so if it's more than 10 quarters, like it is, it says 10.5 quarters, then it won't have reached the 45,000 yet. So we have to go up to the 11th quarter before it safely goes over the 45,000. So looking for over 45,000. And so that is 2 3/4 years. Okay, so by inputting a little bit of some of these values into this TVM solver, we can see with a quick enter key, we can find the missing values, whatever we're looking for. Okay, and I think that is it for today. So there's your fun for today. Please practice with the graphing calculator, and thanks for watching, and we'll see you in class.